You think you're eating healthy, loading up your plate with veggies, right? Well, your liver, the body's detox machine, is under attack, and the enemy? It's not just alcohol or junk food, but certain vegetables you probably eat every single day. Now, let's be clear, not all vegetables are bad, but some contain hidden toxins, liver-clogging compounds, or chemicals that force your liver to work overtime, leading to inflammation, fat buildup, and even long-term damage. In this video, we're exposing 10 vegetables that could be silently harming your liver. By the end of this video, you'll know exactly which vegetables to limit or avoid. Let's get into it. Number 1. Sugar-rich vegetables. All right, let's dive into the sweet and sour tale of how sugar-rich vegetables can wreak havoc on your liver. Picture your liver as the body's diligent detox officer, tirelessly processing nutrients and filtering out toxins. Now, when we introduce an overload of fructose, a type of sugar prevalent in certain vegetables, things start to go awry. Fructose is a simple sugar found naturally in many plants. While fruits are the usual suspects, some vegetables like sweet corn, beets, and carrots also pack a fructose punch. Unlike glucose, which is readily absorbed and utilized by our body's cells for energy, fructose takes a detour straight to the liver. Here, it's metabolized and, in excessive amounts, can lead to the production of fat, a condition known as hepatic steatosis, or more commonly, fatty liver disease. But the plot thickens. Our gut is home to trillions of bacteria, collectively known as the microbiota. These microscopic residents play a pivotal role in our health, aiding digestion and supporting immunity. However, a high fructose diet can disrupt this harmonious community. The excess fructose can alter the gut barrier's integrity, making it more permeable, a phenomenon often dubbed leaky gut. This permeability allows bacteria and their endotoxins to escape into the bloodstream and make an unwelcome journey to the liver. Once these endotoxins reach the liver, they trigger inflammation and oxidative stress. Think of it as your liver's version of a bad hangover. Over time, this chronic insult can progress to more severe liver conditions, including non-alcoholic steatohepatitis and even cirrhosis. Now let's swing over to some compelling research that sheds light on this mechanism. In June 2013, a study conducted at Wake Forest Baptist Medical Center and published in the American Journal of Clinical Nutrition explored the effects of dietary fructose on liver health using a primate model. The researchers aimed to isolate fructose impact without the confounding factor of weight gain. Here's the lowdown. 10 middle-aged monkeys were divided into two groups. One group received a calorie-controlled diet comprising 24% fructose, mirroring the high fructose consumption seen in many human diets. The control group enjoyed a similar diet, but with a negligible fructose content of about 0.5%. Both diets maintained equal amounts of fat, carbohydrates, and protein, differing only in fructose content. Over 6 weeks, both groups were carefully monitored to prevent weight gain. The findings were eye-opening. The fructose-fed monkeys exhibited a more than twofold increase in liver damage markers compared to the control group. Specifically, there was a 30% higher rate of bacterial endotoxin leakage from the gut to the liver. This underscores the role of fructose in compromising gut integrity, leading to liver inflammation and damage. So what's the takeaway from this monkey business? While sugar-rich vegetables in moderation are part of a balanced diet, excessive intake, especially in the form of added fructose, can set off a chain reaction detrimental to liver health. The sequence goes something like this. High fructose consumption disrupts gut barrier function, allowing endotoxins to infiltrate the liver, which in turn sparks inflammation and fat accumulation. Over time, this can escalate to serious liver diseases. To keep your liver in tip-top shape, it's wise to be mindful of fructose intake. Emphasize a diet rich in whole grains, lean proteins, and a rainbow of fruits and vegetables, favoring those lower in fructose. And remember, while our bodies can handle fructose in natural amounts, it's the excess, often hidden in processed foods and sugary drinks that spells trouble for our hardworking liver. Number 2. Starchy culprits. Starchy foods, especially those rich in rapidly digestible starches like white bread, white rice, and potatoes, can significantly impact liver health. When consumed, these foods are quickly broken down into glucose, causing a rapid spike in blood sugar levels. In response, the pancreas secretes insulin to facilitate glucose uptake by cells. However, consistently high insulin levels can lead to insulin resistance, a condition where cells become less responsive to insulin. This resistance prompts the liver to convert excess glucose into fat, leading to fat accumulation within liver cells, a hallmark of non-alcoholic fatty liver disease. A study published in Cell Metabolism in September 2023 investigated the effects of resistant starch on individuals with non-alcoholic fatty liver disease. This 4-month randomized controlled trial involved 200 participants who were divided into 2 groups. One received a daily supplement of resistant starch, while the other received a placebo. The results were promising. The group consuming resistant starch experienced a significant reduction in liver triglycerides and liver enzymes associated with liver injury and inflammation, independent of body weight changes. Number 3. High oxalate vegetables. High oxalate vegetables, such as spinach, beets, and rhubarb, contain significant amounts of oxalic acid, a naturally occurring compound that can impact human health when consumed in large quantities. While oxalates are often associated with kidney stone formation, their potential effects on liver health are gaining attention in scientific research. Oxalates enter the body through dietary intake and endogenous production. Once ingested, they are absorbed in the gut and transported to the liver, where they undergo detoxification processes. The liver converts oxalates into less harmful substances, which are then excreted via the kidneys. However, excessive consumption of high oxalate foods can overwhelm the liver's capacity to process these compounds, leading to accumulation and potential tissue damage. Emerging research suggests a connection between high oxalate levels and liver conditions such as non-alcoholic fatty liver disease. A study published in Mayo Clinic Proceedings highlighted that increased oxalate concentrations might drive the progression of chronic kidney disease and have implications for cardiovascular health. While the study primarily focused on kidney health, it underscores the systemic impact of oxalates, suggesting that the liver, as a central organ in metabolism and detoxification, could also be affected by elevated oxalate levels. A study titled Oxalate Metabolism: From Kidney Stones to Cardiovascular Disease, published in Mayo Clinic Proceedings, explored the broader implications of oxalate metabolism beyond kidney stone formation. The researchers examined the association between oxalate levels and various health conditions, including liver diseases. They found that increased oxalate concentrations could be a driver of chronic kidney disease progression and have potential implications for cardiovascular health. While the study did not provide specific percentages related to liver damage, it highlighted the need for further research into how elevated oxalate levels might affect liver function. For individuals concerned about oxalate intake, especially those with existing kidney or liver conditions, moderating consumption of high oxalate vegetables is advisable. Cooking methods like boiling can reduce oxalate content in vegetables, as oxalates are water-soluble and can leach into cooking water. Additionally, maintaining adequate hydration and ensuring sufficient dietary calcium can help mitigate oxalate absorption in the gut. Number 4. Goitrogenic greens. Goitrogenic greens, such as kale, broccoli, and Brussels sprouts, are often lauded for their health benefits. However, these cruciferous vegetables contain compounds known as glucosinolates, which can interfere with thyroid function by inhibiting iodine uptake, potentially leading to hypothyroidism. This thyroid dysfunction can indirectly affect liver health, as the liver plays a crucial role in metabolizing thyroid hormones. When thyroid function is impaired, it can lead to a cascade of metabolic disturbances that may burden the liver. Despite these concerns, it's important to note that cooking methods can significantly reduce the goitrogenic potential of these vegetables. For instance, steaming cruciferous vegetables can decrease goitrogen yield by about 30%, while boiling them for 30 minutes and discarding the water can remove approximately 90% of goitrogens. This reduction minimizes their potential impact on thyroid function and, consequently, on liver health. Moreover, cruciferous vegetables are rich in compounds like indole-3-carbinol and sulforaphane, which support liver detoxification pathways. These compounds enhance the liver's ability to process and eliminate toxins, thereby promoting overall liver health. In summary, while goitrogenic greens contain compounds that can interfere with thyroid function, their impact on liver health is indirect and largely dependent on individual iodine intake and cooking methods. For most individuals, consuming these vegetables as part of a balanced diet poses minimal risk and can offer significant health benefits, particularly when properly prepared. Number 5. Nightshades and liver stress. Nightshade vegetables, such as tomatoes, potatoes, eggplants, and bell peppers, belong to the Solanaceae family and contain natural compounds called glycoalkaloids, notably solanine and chaconine. These compounds serve as the plant's defense mechanisms against pests and diseases. While they protect the plants, glycoalkaloids can be toxic to humans in high concentrations, potentially leading to adverse health effects, including liver stress. Glycoalkaloids, like solanine, have been shown to disrupt cell membranes, leading to cell damage. In vitro studies have demonstrated that solanine can destroy human liver cells, indicating a potential hepatotoxic effect. This cytotoxicity is primarily due to the compound's ability to interfere with mitochondrial function, leading to increased oxidative stress and apoptosis, or programmed cell death in liver cells. An animal study highlighted the potential risks associated with glycoalkaloid consumption. In this study, Syrian hamsters fed diets containing solanine exhibited significant gastrointestinal tissue damage. While this study focused on the digestive tract, it underscores the broader cytotoxic potential of glycoalkaloids, which could extend to liver tissues. It's important to note that the glycoalkaloid content in nightshade vegetables varies based on factors like species, cultivation conditions, and ripeness. For instance, potatoes can contain anywhere from 25 to 275 micrograms of alkaloids, depending on the type and where they were grown. Tomatoes have higher alkaloid concentrations in their stems and vines than in the fruit, and as tomatoes mature, the amount of alkaloids in the edible part decreases. While these studies provide insights into the potential risks of glycoalkaloids, it's essential to recognize that the concentrations used in experimental settings often exceed typical dietary exposures. Most people consume nightshade vegetables without adverse effects, and these foods are rich in nutrients like vitamins A and C, potassium, and fiber. However, individuals with existing inflammatory conditions or sensitivities might experience exacerbated symptoms upon consuming nightshades. Some anecdotal reports and preliminary research suggest that nightshades may increase inflammation in certain individuals, but they do not cause inflammation directly. Before we continue, if you have been enjoying the video so far, hit the like button and don't forget to subscribe and hit the bell icon so you don't miss more videos like this. Number 6. Mold-prone vegetables. Mold-prone vegetables, such as corn, peanuts, and certain grains, can harbor molds that produce mycotoxins, nasty little compounds with a penchant for wreaking havoc on your liver. When these contaminated foods are consumed, mycotoxins like aflatoxins are absorbed into the bloodstream and make a beeline for the liver, the body's primary detoxification hub. Once there, they can form reactive intermediates that bind to cellular components, leading to oxidative stress, DNA damage, and over time, serious liver diseases, including cancer. A compelling study highlighting this danger was conducted in the United Kingdom and published in the journal Equine Veterinary Journal in 2025. Researchers investigated outbreaks of liver disease in horses and their potential link to mycotoxin-contaminated forage. They identified 29 premises where 4 or more horses were affected by liver disease and collected forage samples from these locations, as well as from 12 control premises without liver disease cases. The analysis revealed that a significant percentage of the forage from affected premises contained high levels of mycotoxins, establishing a strong association between mycotoxin exposure and liver disease in these animals. While this study focused on horses, the implications extend to humans, as similar mechanisms of mycotoxin-induced liver damage have been observed across species. Therefore, it's crucial to ensure proper storage and handling of mold-prone vegetables to minimize mycotoxin contamination and protect liver health. Number 7. Pesticide-heavy choices. Pesticides, those chemical concoctions designed to keep our veggies pristine, can sometimes play the villain in our body's story, especially when it comes to our liver. When we consume vegetables laden with these chemicals, they hitch a ride into our system, making a beeline for the liver, our body's detox maestro. The liver's job is to break down these foreign invaders, but certain pesticides can throw a wrench into this well-oiled machine. Take organophosphorus pesticides, for example. Widely used in agriculture, these compounds are known to induce liver damage upon both acute and chronic exposure. A comprehensive review spanning 4 decades highlighted that organophosphorus pesticides could lead to significant liver dysfunction. The mechanisms. They involve oxidative stress, where an imbalance between free radicals and antioxidants wreaks havoc on liver cells, and disruptions in lipid metabolism, leading to fatty liver conditions. Another study zeroed in on dichlorvos, a specific organophosphorus pesticide. Researchers discovered that dichlorvos exposure in rats led to liver injury through mechanisms dependent on reactive oxygen species and autophagy. Specifically, dichlorvos downregulated immunity-related GTCase-M, a protein involved in autophagy, suggesting that impaired autophagy played a role in the observed liver damage. But it's not just about individual pesticides. A study investigating mixed exposure to non-persistent pesticides found a significant association with increased risk of liver fibrosis in humans. This underscores the potential cumulative effect of multiple pesticide residues in our diet, highlighting the importance of considering combined exposures rather than isolated chemicals. Moreover, certain pesticides have been linked to more severe liver conditions. For instance, exposure to glyphosate, the active ingredient in many herbicides like Roundup, has been associated with more severe cases of non-alcoholic fatty liver disease. This connection raises concerns about the widespread use of such chemicals and their long-term implications for liver health. Number 8. Excess iron-rich veggies. Iron is an essential mineral vital for numerous bodily functions, including oxygen transport and DNA synthesis. However, like that friend who overstays their welcome, too much iron can become a problem, especially for your liver. The liver plays a central role in regulating iron balance, acting as the body's storage hub for this mineral. When we consume iron-rich vegetables, such as spinach, kale, and broccoli, we introduce non-heme iron into our system. While non-heme iron is less readily absorbed than heme iron from animal sources, excessive intake can still lead to iron accumulation, especially in individuals with certain genetic predispositions or underlying conditions. Once in the body, iron doesn't just float around aimlessly. It's absorbed in the intestines and transported to the liver for storage or distribution. The liver, being the diligent worker it is, produces hepcidin, a hormone that regulates iron absorption and distribution. Think of hepcidin as the traffic cop for iron, directing where it should go and ensuring there's no congestion. However, when there's an overload of iron, this regulatory system can get overwhelmed. Excess iron in the liver catalyzes the formation of reactive oxygen species, those pesky free radicals that can damage cellular structures, including lipids, proteins, and DNA. This oxidative stress can lead to inflammation, fibrosis, and, over time, serious liver diseases such as cirrhosis or hepatocellular carcinoma. A study published in the Journal of Hepatology delved into the mechanisms of iron-induced liver toxicity. The researchers highlighted that while the liver is resilient, excessive iron can tip the balance, leading to cellular damage. They noted that the human body has a natural tendency to retain iron, making it susceptible to overload and toxicity. Despite this, the liver's resilience means that additional factors are often required for significant damage to manifest. Another intriguing study, conducted on laying hens and published in Biological Trace Element Research, explored how dietary iron overload affects liver health. The researchers developed a model of hepatic iron overload by incorporating iron into the hen's diet. They discovered that excessive dietary iron led to significant liver injury, characterized by increased oxidative stress and inflammation. While the exact percentages weren't specified in the summary, the study underscores the potential risks of excessive iron intake from dietary sources. It's essential to note that not everyone who munches on iron-rich veggies is at risk. The body's iron absorption is a finely tuned process, influenced by factors like current iron levels, the presence of enhancers like vitamin C, and inhibitors such as certain phytates in the diet. However, individuals with genetic conditions like hereditary hemochromatosis, where the body absorbs more iron than necessary, need to be particularly cautious. For them, even the iron from vegetables can contribute to overload. Number 9. Overconsumption of cruciferous vegetables. Cruciferous vegetables. Think broccoli, cauliflower, kale, and Brussels sprouts are often hailed as nutritional powerhouses, packed with vitamins, minerals, and unique phytochemicals. One such compound is indole, a natural substance found in these veggies. Interestingly, research indicates that indole might play a role in combating non-alcoholic fatty liver disease. A study led by Texas A&M AgriLife research scientists, published in Hepatology in 2020, demonstrated that indole can reduce inflammation and fat accumulation in the liver. This study explored how indole interacts with gut bacteria and its subsequent effects on liver health. The researchers found that indole helps control non-alcoholic fatty liver disease by influencing gut bacteria composition, reducing inflammation, and decreasing fat deposits in the liver. This suggests that incorporating cruciferous vegetables into one's diet may have protective effects against liver diseases. Moreover, an umbrella review of 41 systematic reviews and meta-analyses, encompassing 303 observational studies with over 13 million participants, found suggestive evidence that cruciferous vegetable intake is associated with beneficial effects on several health outcomes, including reduced risks of certain cancers and all-cause mortality. Number 10. Oxidized fat-absorbing vegetables. When we talk about vegetables absorbing oxidized fats and their impact on liver health, it's essential to understand the underlying mechanisms and supporting research. Oxidized fats, often resulting from the heating of vegetable oils, can lead to the formation of harmful compounds that adversely affect liver function. A study titled Association of Long-Term Consumption of Repeatedly Heated Mixed Vegetable Oils in Diet and Hepatic Steatosis, Damage, and Non-Alcoholic Fatty Liver Disease explored this phenomenon. Published approximately 4.9 years ago in Lipids in Health and Disease, this research investigated the effects of consuming thermally oxidized vegetable oils on liver health. The study utilized rabbits, an appropriate model due to their lipid metabolism similarities with humans. Over a period, rabbits were fed diets where 57% of their caloric intake came from fats, specifically focusing on the impact of oxidized oils. The findings revealed that such a diet led to hepatic steatosis or fat accumulation in the liver damage, and the development of non-alcoholic fatty liver disease. The mechanism behind this involves oxidative stress. When vegetable oils are repeatedly heated, they undergo oxidation, producing reactive oxygen species and other harmful compounds. Upon ingestion, these oxidized fats can overwhelm the liver's antioxidant defenses, leading to lipid peroxidation. This process damages liver cell membranes, disrupts mitochondrial function, and triggers inflammation, all of which contribute to liver injury and diseases like non-alcoholic fatty liver disease. Furthermore, the consumption of oxidized fats has been linked to the formation of toxic aldehydes, such as crotonaldehyde. Detected in various food systems, including fried vegetables, crotonaldehyde has been shown to cause liver damage and hepatic tumors in animal studies by forming DNA adducts. So these were the top 10 vegetables that are destroying your liver. Now we want to hear from you. Which of these vegetables surprised you the most? And which of them were part of your diet? Share with us your experiences and opinions in the comments below. We love to hear them. Thanks for watching.